Hi everyone, it's Mrs. Bebo. In this video, we're going to take a look at calculating percent error. The main goal for this video is how do I solve problems involving percent error. In this video, the vocab that we're going to need to know is percent error and amount of error. The percent error is a ratio written as a percent that compares the inaccuracy of an estimate or the amount of error to the actual amount. The amount of error is the positive difference between the estimate and the actual amount. To find the amount of error, we're going to subtract the lesser amount from the greater amount. And throughout this video, we're going to use what I have highlighted in just giant letters down there at the bottom is a proportion. I find that my students have worked a lot better using a proportion to solve this type of problem. Much like percent change, it looks very, very similar. So that's what we're going to use throughout this video. Percent over 100 equals the amount of error over the actual amount. All right, so taking a look at our first example, it says a contractor estimates that it will take him 16 hours to complete a home improvement project. It actually takes him 12 and a half hours. What is the percent error of the contractor's estimate? So you can see I already have written out our proportion. P over 100, so the percent over 100, is equal to the amount of error over the actual. So we're solving for the percent error. So that is still going to be my unknown value. The amount of error we can actually find. So the amount of error, again, is going to be the difference between your estimate and the actual, or the actual and the estimate. Again, you're just going to do the greater value minus the lesser value. So 16 minus 12 and a half, and that's going to tell me the amount of error is 3 and a half. So in my proportion, I'm going to have 3 and a half at the top of this ratio on the right-hand side. And then the actual time is 12 and a half. So that's going to go on the bottom of this ratio on the right-hand side. And now we just do our cross products. So we're going to do 12 and a half times P. We'll do 3 and a half times 100. We'll have 12 and a half P is equal to 350. And then we just have one more step. To solve this equation that we have left here, we're going to divide both sides by that 12 and a half. And we are going to find that our percent error is 28%. And then that's it for that question. All right, taking a look at example 2, we're going to do the same idea. A town has a population of 855 residents. While giving a tour of the town, a resident says the population is 900. We're going to find the percent error of the resident's estimate. Round to the nearest tenth if necessary. So again, with our proportion, it's the percent over 100 equals the amount of error, or some of my students have said it's the change in error, right? The change in the two amounts. So the amount of error over the actual. So the amount of error, again, is just the change. It's the difference between those two values. So if I take a look at this question, the town has a population of 855. That is the actual. The resident's just estimating and saying, hey, it's about 900 people. So the amount of error is going to be 900 minus 855, and that's telling me 45. So my proportion is going to look like the following. P over 100 is equal to 45 over 855. Because again, 855 was the actual town population. Now we're going to do our cross products. So we're going to have 855 times P, so that's just 855P, equals 45 times 100, so that's 4,500. And then we have one more step to solve this. Divide both sides by 855, and then we're going to find our percent. When we get this answer, we are going to have to round to the nearest tenth. And so we get, 5.26 and some change there. Rounding to the nearest tenth, this is going to be approximately 5 3/10%. And so that is our final answer on this one. All right, so taking a look at another one, just so we can really make sure that we get how this works. Jane walks into a concert hall and estimates that there are 1,500 seats in the hall. There are actually 1,763 seats in the hall. What is the percent error of Jane's estimate? We're going to round to the nearest tenth if necessary. So once again, we are using that percent over 100 equals the amount of error over the actual. So that is the proportion that we're using to solve these percent error questions. I don't know what my percent is, So that's still going to be my unknown. My amount of error, again, is going to be the difference in your two values. So we're going to be doing 1,763 minus 1,500. That's going to tell me a difference of 263. So 263 is my amount of error. The actual is the 1,763. And a lot of times with these percent error questions, they do use those words, the estimate and actual. So make sure you're looking for those keywords. Maybe you have to read through the question a couple of times. But yeah, just make sure that you are looking for the actual to put at the bottom of that proportion there. All right, so doing our cross products, 1,763 times P is exactly how it sounds. The 263 times 100 is going to be 26,300. And then we have one more step, which is to divide both sides by that 1763 there. And once again on this one, we're going to have to round. So we get P is approximately, and it was 14.917 and so on. It's going to stay at 14 and 0.9%. And that's it for that question. All right, so we're going to take a look at two a little bit more complicated examples. In this first one, it says a school newspaper estimates that their basketball team will win 23 out of 25 games for the season. After 10 games, they have won 8. If the team continues winning at this rate, what will be the percent error of the newspaper's estimate once the season is over? So with this question, you do have some options. So basically we have these two winning rates, right? We got 23 out of 25, that's the estimate. And then the actual is that they have won 8 out of 10. So that's what's actually currently happening. So they're trying to say, okay, what is going to be their percent error if they continue winning at that rate with the newspaper's estimate? Now, these rates, they can be represented as, again, a fraction, 23 out of 25, right? 8 out of 10. You can also represent them as decimals, and we can also represent them as percents. So my advice to my students is to get those rates written as a percent, because then it's going to be like you're dealing with, you know, quote unquote whole numbers, and not have to worry about common denominators, or again, even just working with decimals sometimes can be tricky. So whole numbers is a good way to go. Again, we're just technically getting that percent form. So 23 out of 25, we can divide and then multiply that by 100 to find the percent there. So 23 divided by 25, multiply that by 100, you get 92%. Now for the actual, we have won 8 after 10 games. So a 8 out of 10, which if you have to do the math, 8 divided by 10 multiplied by 100, but hopefully you know that 8 out of 10 is going to be an 80%. So that's what they're currently doing. They're currently winning 80% of their games. So what is the percent error? Again, we set up our proportion, percent over 100 equals the amount of error over the actual. We don't know what the percent is. That's what we're trying to calculate. The amount of error is the difference between those two winning rates. 92 minus 80 is going to tell me 12. And the actual was what I have written in blue, 80%. And now I can do my cross products and solve. So 80 times P, again, it's just 80P. 12 times 100 is 1200. Last step to solving this proportion is to divide both sides by 80. And 1200 divided by 80 is 15. So our percent error in this case is 15%. All right, so let's take a look at one more that's pretty similar to this last one that we just talked about. A sports journalist estimates that a certain football team will win 9 out of their 12 games this season. After 3 games, the team has won 2. If the team continues winning at this rate, what will be the percent error of the journalist's estimate once the season is over? So on this one, again, we have our estimate here. So 9 out of 12. And so again, we can go through and calculate our percentage by doing 9 divided by 12 and then multiplying that decimal by 100, and it ends up being 75%. Now, the 2 out of 3 is not going to be a nice one, so we're going to end up rounding on this one. The question probably should state that we're going to have to round at some point. So after 3 games, the team has won 2, so a 2 out of 3. And And then if we multiply that by 100, it's going to be approximately 67%. It's like 66.6 repeating percent to be exact. So we're just going to round and say that's 67%. Now, when I set up my proportion, now that I have those winning rates calculated, percent over 100 is equal to the amount of error over the actual. And then we just plug in the information that we know. So we know we don't know the percent, excuse me. That's going to be over 100. The amount of error, we're going to do 75 minus 67, and that ends up being 8. And the actual score, or the rate at which they're winning, is going to be the 67%. Then we're going to do our cross products and solve. So 67 times p is going to be 67p. 8 times 100 is 800. And then last step is to divide both sides by what p is being multiplied by, in this case 67. And we're going to find that our percent is approximately equal to, we're going to say 12% in this case. Ends up being 11.94 again and some change. So we'll just round to the nearest whole percent since we did that earlier with our winning rate, and we get 12% error. And that's it for percent error using a proportion to solve those types of questions. Thanks for watching.